Now, I expect you to be familiar with these three. I do want you to be able to generate a power series on your own using both what we know about a geometric series and secondly, using the brute force technique. There's a third technique, but I'm going to leave it for you to read. It's called the binomial series expansion. So read up on the binomial series, know what it is. It's a small extension from what we did back in pre-calculus with the binomial theorem. Do you mind if I just briefly discuss how sometimes I can be as silly as this to evaluate limits? So question, can you and I use power series to evaluate that limit? Well, I think the limit becomes this. Now, the cosine of x has a power series representation here. If you multiply every one of these terms by -1, you get this. Sine of x has a power series as this. At least in expanded form. Looks to me like these ones are going to cancel out front. You can clearly see I made the example of it in such a way that those ones do cancel. However, take a peek at how if you pull out a factor of x upstairs and downstairs, and then cancel that like factor of x upstairs and downstairs, here's what remains standing. Now take a peek at how if you evaluate x equals 0, every term upstairs goes to 0. Every term except for the first downstairs go to 0. So aren't we really left with 0 divided by 1? Or shall we just say simply 0? And everybody, I admit that's a waste of time. In a sense, that it's a contrived example in that. If I really wanted to evaluate this limit, I can get it done in one step with L'Hopital's rule. And I do get the same thing because sine of x over cosine of x divided 0 is simply going to be this. But just an illustration that I can play with power series. And if this were a test question, it would simply be a question on a test so that I can see you can manipulate or massage these power series.